31. So we have absolute value equations. So notice here at the top, there are 3 steps. And what's going to end up happening in step 3, you're going to be writing this one equation as 2 equations. So the very first step says isolate the absolute value bars. So once these bars are isolated, that means you don't have any other numbers over here with it. Then you'll separate them. You'll drop the bars and you'll separate it into 2 equations. And I'll show you how to do that. Now you might ask, well, why do we separate it into 2 parts? Okay, let's take a look at this question number 2. Step 1 is done because the bars are isolated. Step 2 says remove those bars, remove the symbols, and then write your 2 equations. Well, if I ask you this question, what could the value of P inside of here be in order for this to equal to 9? Well, P could either be positive 9 or P could equal to negative 9. Is that a true statement? Yes, because when we take the absolute value of a negative number, it equals to a positive. And when we take the absolute value of a positive, it will equal to a positive. Okay, so that's why you're going to drop the bars and then you're going to write your 2 equations, set it equal to the negative and the positive. Then you just simply write your answer in the little set brackets. And it doesn't matter which one you write first because these are not coordinates. Okay, they're just solutions. They're not coordinates. Going to question number 3. So we're going to follow the steps. The bars are already isolated. So step 1 is done. We're going to remove those bars. So I'm going to say 6n plus 7 equals to 23. So when you remove the bars, you simply write it exactly like you see it first. And then when you write it the next time, 6n plus 7, you just set it equal to negative 23, just like we did in the first example. So now we just go ahead and we can solve this for n. So we'll have 6n equals to what? 16. Divide by 6. So n, and we'll just reduce this. Don't use mixed numbers. So that'll be 8 over 3. Okay, we'll subtract 7 here. 6n equals negative 30. So n equals to negative 5. So again, just write your 2 answers in set notation. And it doesn't matter which one you write first. Okay, let's take a look at question number 4. In question number 4, step 1 is not done because there's a 4 over there with the absolute value symbol. So I'm going to divide by 4 because 4 is being multiplied by that absolute value. So I'll divide both sides by 4. So I'm going to end up with the absolute value of n equals 10. Now the bars are isolated. I'll drop the bars and say n equals 10 or n equals to negative 10. And then put those in the set notation. All right. All right, moving down to question number 3. Okay, let's go down to 3. Sorry, not 3, 6. All right, in question number 6, negative 3 is being multiplied by the bars. So I'm going to divide by negative 3. So I'll have the absolute value of 8 plus 9n equals to what? All right, 37. So now I can drop my bars and write this as 2 equations equals to negative 37 and positive 37. And that should be an n. All right, go ahead and finish solving those and see what you get. So for the first one, you should end up with 29/9. And for the second one, you should end up with -5. Okay. All right, we're going to do one more on this page before we move on. We'll do number 7. Now, in number 7, we have a couple of numbers over here with the absolute value symbols. So which one do we eliminate first? Would be the 10. All right. Anything that's being multiplied or divided, we do that later. So in this case, we'll at least multiply. So we're going to now subtract 10. So that will give me -9 times 3 minus 5r equals -117. Okay, then we will divide by the -9. And we have 3 minus 5r equals to 13. Okay, so we'll write our two equations, dropping the bars. 3 minus 5r equals 13, and 3 minus 5r equals to -13. All right, go ahead and solve it from there. All right, so for this, you should have r equals to -2 and r equals to 16/5. And then we'll just put those in our set notation. Again, it doesn't matter which one you write first because these are not coordinates. And that's another reason that we use the set brackets and not parentheses. They're not coordinates. All right, now there's always a special case where you might not have a solution. So in this case right here, it says absolute value equations cannot be solved if the absolute value has been isolated and the equation equals to a negative number. So once you isolate the bars, if it equals to a negative number, then you simply write no solution. So like this one here, the bars are isolated, but it says equals a -3 because you cannot take the absolute value of any number because when you do that, it's a positive number and a positive number cannot equal to a negative number. Okay, so this would be a no solution problem. So you wouldn't go any further. Once you isolate and you see, oh, wow, this equals to a negative, then you stop. Same thing for number 10. If I subtract 6, okay, let's work it out. And then I divide by this -7. See how once I isolate the bars, it equals to a -8. So you will stop and write no solution. All right, now on the next page, this is where you'll see the title that says absolute value inequalities, and then it says less than and. So that's from our previous lesson. The word and means the intersection. So here we're going to do the same thing. We're going to still isolate the bars, but since these are inequalities, when we set it equal to the negative and the positive, we'll also have to reverse the inequality symbol. Okay, you can see how the symbol will be reversed and then write it as the negative part of it. Okay, so that's a little different. You got to make two switches for inequality. So not only do you say the positive and the negative, but then you got to also reverse the inequality symbol. Now, let me go over what this means up here. There are two ways, and it says right here, note for and statements, there are two options. Same procedure for both, less than and or less than and equal to. So if this had been less than or less than equal to, you have two options. Remember in the lesson, from the previous lesson, and is the invisible word. So sometimes you'll see the word and like this, and sometimes you will not. So for compound inequalities, because these are going to end up turning into compound inequalities, you can write this as an and statement where you don't see the word. Some students like to write it this way. Some students like to write it this way. So I'm going to show you both options. Okay. So let's take a look at, and I want to start with 13. So let's take a look at 13 first. So in question number 13, if I write it where you don't see the word and, you're going to put what's inside of the bars because they're already isolated, so I don't need to do anything for my first step. I'm going to put that in the middle. And then I'm going to put my less than symbol here. Right? And then I'm going to put a less than and put -6 over here. So that is how I would write this compound inequality without using the word and. Now let me show you the other option. The other option would look like this. You write it just like you see it. Okay, that's that. And then it's going to be x plus 1 is, and here's the change, it's greater than -6. So the word and would be in between. Okay, so that is how you would write it if you want to write it out with using the word and. You write it just like this, and then when you write the second one, you reverse the symbol and write the negative number. It's totally up to you which one you want to use. If you want to write it as a compound inequality, you use less than symbols and put the smaller number over here and the greater number here. You'll get the same answer either way. So let's work it out, and I'll work out both. So I'm going to subtract 1 from the middle, from both sides. I end up with -7 is less than x is less than 5. Good thing about this particular one, it came out already in set builder notation because my smaller number is here, my variable's in the middle, my larger number is last. So I don't even have to make any changes except for put that such that symbol, and there's your answer. Now, if I do it where I write the word and, I just write them or solve them like two separate problems. X plus 1 is less than 6, subtract 1, x is less than 5. Okay, x plus 1 is greater than -6, x is greater than -7. So this -7 is less than x is equivalent to x is greater than -7. So when I put this in set builder and I have to reverse the number to the other side, you get the same answer. Okay, so it really doesn't matter which option you choose. If you want to write it as two separate problems, just making sure you switch this to greater and then negative, you can definitely do that. Okay. All right. Let's move on to question 14. Now there's something over here with the absolute value bar, so we have to do step number 1. So this we're going to divide by 6. And that gives me 13. Now I want to stress something and go back at the top. Notice how up here it says less than, and this also represents less than or less than equal. It's an and statement because when we get to greater, it's going to be for or statements. Okay, so just make sure you know the difference. Okay, so now we're going to either write it as a single compound inequality or a separate. It's totally up to you. I'll do both. So I'm going to drop the bars. I'm going to put the -13 is less than negative 8x plus 3, which is less than 13. Okay, that's how you would write it without using the word and. And then you can solve it from there. Okay, if you want to do the other way, and I'll put it off to the side, I would have the absolute value of negative 8x. Hold on, let me drop my bars. Okay, I'll just rewrite it as what you'll start off with. Plus 3 is less than 13. And here's my and. Negative 8x plus 3. Here's my switch. Is greater than negative 13. So it's totally up to you which way you want to do it. Okay, I'll let you guys make that decision. I'm only going to solve one of these. So I'm going to go back to the way that I wrote it first without the word and go ahead and subtract 3 from all sides. So negative 16 is less than negative 8x, which is less than 10. From there, I need to divide all sides by negative 8. So I'm dividing by a negative, so what should I do? I have to reverse the sign. So 2 is greater than x, which is greater than negative 5/4. Now, this is not in set builder notation. Can anyone recognize why this is not in set builder notation? Well, besides being greater than, then also my smaller number is not written first. That's correct. So when I do switch it and write my smaller number first, then all the signs will change to less than. All right, so my final answer would be x such that negative 5/4 is less than x, which is less than 2. Just like we had a special situation for the equations, there's also a no solution for less than inequality. So it says the absolute value is isolated, and if you end up with a negative number that's less than a negative number, then you have no solution. So if you can recognize right away, you don't do any work. Here it is. It says the absolute value of 8 minus b is going to be less than negative 58. Well, there's no positive number that can be less than a negative number, correct? All positive numbers are greater than negative numbers. So in this case, you would simply write no solution. This one wasn't a good example, so just scratch that out of a no solution, because actually when I worked it out, the signs flipped, so that's the difference. That one did not come out correctly. This one, again, just remember, if you come out with less than a negative number, you simply write no solution. All right, let's move on to the last part. This is part 3. So now we see this word, greater, which will represent or. And from your previous lesson, or means the union. Now, good thing about it, there's only one way to write an or statement, because remember, from the lesson, you always see the word or. It's always going to be visible, okay? So there's only one option to write it. So let's go ahead and let's start with 21 first. So again, bars are already isolated. So we're just going to go ahead and separate these. But again, please pay attention, because on your test, you're going to have to look at, your symbols to determine whether it's a greater than or less than and. So here, they're all put together for you because we're doing now all greater than. But on your test, they'll be switched up. One problem could be a greater than absolute value problem. One problem could be a less than. So you have to make sure you pay attention to the inequality symbol so you'll know if you're looking for and or. All right, so here we're going to drop the bars. 1 minus 2n is greater than or equal to 3. You write it exactly like you see it without the bars. Then you write the word or. 1 minus 2n, here's the switch, less than or equal to -3. Okay. And then you just solve it from there. You just solve it just like you normally would. So go ahead and solve it. Okay, I'll solve it up here. You can solve it on your paper. All right, so I ended up with n is less than or equal to -1, or n is greater than or equal to 2. So, remember for or, you don't combine them together. You just put the word or in between, put your such that symbol, and then your set brackets. And it doesn't matter which one goes first. Okay, you just simply write both answers, put the word or in between. Okay, let's go ahead and do number 1. It's a very basic one, but it's already been isolated. So we write it exactly like we see it first. X is greater than 9, or X is less than -9. And then put your such that symbol and your set brackets, and you're done with that. All right, let's do number 25. Okay, we're almost done. So we're going to subtract 5 from both sides. And I end up with the absolute value of 6 plus k is greater than or equal to 1. All right, now they're separated, so we can they're isolated, so now we can separate them into 6 plus k is greater or equal to 1, or 6 plus k is less than or equal to -1. Okay, I'll let you guys finish solving those. Now, just as before, there's a special case where you could have all real numbers for or problems, the greater problems, the greater equal and the greater inequality symbol. So here's the statement up here. If the variable has been isolated and the inequality is greater than a negative number. Here we go. This says absolute value of 9 plus 7p is greater than -40. You simply write all real numbers. Okay, or you can do the real number symbol. So if it's greater than a negative number, because all positive numbers will be greater than a negative number, so that's why you're going to have all real numbers. Okay, so let's work out number 28. That'll be the last one we do. So we're going to subtract 12. So I'll have -10 times the absolute value of 3 minus 4v is greater than 30. Okay, then we'll divide by -10. And actually, this is going to actually come out to be less than, isn't it? Because I'm dividing by a negative. So really, this is not all real. So what would this be? This would be actually a no solution problem. Less than a negative, guys, would be a no solution. So we have 1 all reals and 1 no solution. Okay. All right, so any ones that I did not do from pages 31 to 33, go back and finish those up first. Pretty.